Thanks, David. So I want to talk about a PredictX tool called Simulation Engine. And what Simulation Engine, how it came about was we wanted to enable travel managers to plan an optimal program in a better way. Um, and this came about because if you cast your minds back before COVID and think about the way in which people sort of plan programs for future years, they look at previous year, they tweak that with any major trends they knew that were going on, either in the marketplace or the business, or anything to do with supplier consolidation, and then they'd allocate budgets and conduct everything that they need to conduct based on that. Now, obviously, COVID happened, and now we're in a sort of pseudo return to travel environment where travel managers are not able to do that. So they're faced with an environment full of rapidly changing rates and volumes, completely unpredictable travel volumes and travel and different areas where there's no travel whatsoever, and other areas that are going to be almost back to normal. Big changes in air schedules and hotel closures and inventory shortages, changes in work from home policies, geographic shifts, and office visit and customer visit policies as well. And all of these kind of conspire to make it very obviously that 2022's program is not going to be 2019's with some tweaks. So in order to enable people to be able to plan in this environment, we built Simulation Engine. And Simulation Engine's an application that allows you to predict what future outcomes will be based on both historical data, market data, and complex models that are built on top of that. So, for example, so what it does is it allows you to bring in all the data around your program, add differences that you know about. So if you know, for example, there's not going to be any transatlantic traffic in 2022, you can take that out of the program. If you're considering policy changes and sourcing changes, you're able to bring that in. It brings in market information around fare and rate volatility, so what's happening in the marketplace, and lets you apply a suite of models to that data to predict the outcomes. So you can you can build a lot of scenarios on top of each other and have a forecasted outcome displayed to you in a way that allows you to manage complex changes into your program. We can also do the inverse, which allows us to kind of have a goal. So a goal might be a budget or a budget that's been perhaps slashed by 50%, or a CO2 emissions target, and Simulation Engine will tell you how to get to that budget, or will give you some options that for what you want to change in the program to get to that. I'm going to give you a quick example in this video. So it's a little bit small, but within that, this is a very simple example. It's a trip forecast. And as we go into it, it's using, and you can see on the top, within Simulation Engine, there's a data set and a model for every simulation. So this is using what we call trip profile, and it's using trip forecaster as the model on that. And it's going to give us predicted trip costs, total predicted trip costs for a specific city pair that I'm going to look at here. And it's going to be London, and the destination is going to be New York. So by selecting these, it's again using historical data coupled with market data, specific number of travelers in there, and specific number of days. I'm then going to click Run and apply the model. And what you'll see on here is a predicted cost for I think it's two travelers for 3 days. Total predicted cost with a range of a confidence range on that. How that cost breaks down into the specific spend categories, and not just air and hotel, but we're using total T&E data here. So you've got food and beverage and ground transport, CO2 emissions, and a little bit about the data set that we're using to model this. You can also save these simulations and start to build them up on layer by layer. And by doing that, what this would enable you to do is things like it would enable you to set budgets with confidence for a specific amount of travel that people know they're going to undertake. You can also use, there's another set of models in there that can be used to model policy change impacts, travel patterns, home working. If one example, we've got 20% home workers need to travel to the office all the time, stuff like that, and to achieve a carbon emissions target. Because you can layer these, you can start to build up quite complex differences. This is not what if scenarios. It's not changing one thing, right? It's changing 20 things and having it present what the outcome is. It's totally extensible. It's you can plug any data set in. You can actually plug a non-travel data set in, and we can drop models from a library of models that we're constantly expanding on. Um, it's because we're using to do this two-way communication between the user and the data science engine. It's impossible to do this with things like BI solutions. This is a stage beyond BI. It's a true data science for travel application. In terms of using it, it's packaged as a PredictX module. It sits on top of the PredictX data platform, so that anybody wanting to implement can take advantage of, who's not a current PredictX customer, can take advantage of our pre-existing connectors to over 100 different data sources. It's available now. We have current users in finance and in technology who are using this today. We've had a lot of interest on that. So to sum up, return to travel is obviously going to be a process. There's going to be backwards and forwards elements to it. It's going to require different tools to ensure optimal programs, like the simulation engine, which allows you to model completely different changes, bring in business data, market data, and suggest changes that will produce a desired outcome. It's unique in the marketplace, and it's the next phase of analytic decision support, and we have people using it today.